Hello everyone. My name is Upahar Shrestha, and in this video I'll briefly explain what I learned in this week's programming session. The main topics I learned were class objectives, uh, constructors, object references, parameter passing, string operations, UML, class diagrams, and implementing a class in Python. I also worked on a practical programming problem involving a regular polygon class. First, I learned about classes, objects, and constructors in Python. A class is a blueprint that defines the properties and behavior of an object. An object is an actual instance created from that class. For example, in the first question, we had a class called A with a constructor. The constructor requires a value for I. The problem was that the program tried to create the object using uh, A brackets without providing the required argument. So the correct approach would be something like A5. This helped me understand that when a constructor requires a parameter, those parameters must be provided when creating the object. Constructors are useful in real world programs because they allow an object to be created with its initial information. For example, a student class could use a constructor to set the student's name, ID, course when the object is created. Another important concept was object references and parameter passing. In the count example, the program creates a count object with an initial count of 0. The increment function increases the count by 1. After the loop runs 100 times, the output count is 100, but the output for times is 0. This was an important insight for me because it showed me the difference between modifying an object and modifying a simple value. However, times is an integer. When the times plus is equals to 1 is performed inside the function, it does not change the original times variable in the main. I also learned several string operations in Python. For example, I worked with the string function and string function good morning, and used operations such as count, upper, lower, find, rfind, string indexing, and slicing. I also used comparison operators such as equals to, less than equals to, greater than equals to, and is not equals to. These operations are useful in real-world applications such as processing usernames and searching text, validating information, and manipulating data entered by users. The main practical task was creating a regular polygon class. The class contains 4 data fields. The constructor uses default values of 3 for the number of sides, 1 for the side length, and 0 for both x and y conditions. I also implemented assessor and mutator methods, including getN, setN, getSide, setSide, getX, getY, and setY. The class also contains 2 important methods, getPerimeter and getArea. The perimeter is calculated by multiplying the number of sides by the length. The area uses the regular polygon formula with the tangent function from Python's math module. The program then displays the perimeter and area for each object. I also created a UML diagram showing the attributes, constructor, and methods of the regular polygon class. This helped me understand how a UML diagram can be used to plan the structure of a class before implementing it in the code. The tutorial specifically requires the class structure, UML diagram, and implementing and testing. One challenge I experienced was understanding why changing count inside a function changes the object's value. While changing the integer times does not change the original variable, another challenge was understanding the area formula for a regular polygon and translating that mathematical formula into Python code. However, testing the program and checking the output helped me understand these concepts better. I also learned that creating a class with methods makes a program more organized and reusable instead of putting everything into one large block of code. The UML diagram also helped me visualize how the attributes and methods are connected within a class. Overall, this programming session helped me develop a better understanding of object-oriented programming in Python. I learned how to create classes and objects, use constructors, create accessor and mutator methods, work with object references, manipulate strings, and design and implement a class using a UML diagram. I can also apply these concepts to real world systems such as student management systems, banking applications, library systems, and other software where different objects need their own data and behavior. The biggest insight I gained is that object oriented programming helps make programs more organized, reusable, and easier to maintain. Thank you for understanding. Thank you for watching.